The appearance of a comet is well known to all. You may readily find movies, pictures, and videos of comets online, but have you ever seen one with your own eyes on a dark night? For instance, you probably heard about the Neowise comet last year. It is a comet that the Neowise Space Telescope found on March 27, 2020. On July 3rd, it reached perihelion, and on July 23rd, it came the closest to Earth. Many folks walked outside to view that beautiful comet. These images show the Neowise comet. Include pictures, incredible. What if I told you that our solar system is being approached by a large comet that is coming from the Oort cloud? Learn more about Comet Bernardinelli-Bernstein, also known as C/2014 UN-271, by following me in this video. Therefore, we have a good idea of what a comet looks like. However, before we can discuss this amazing newly discovered comet, we must first understand what a comet is. In fact, it might be challenging to discern between asteroids, comets, meteors, and other objects if you're not an astronomer. A comet is an object made of ice, rock, and dust that orbits the sun and can have a diameter of many miles. Many meteoroids are made of cometary debris. A meteoroid is a tiny rock or metal item that orbits the sun and is typically between the size of a boulder and a grain of sand. It comes from an asteroid or comet. A meteor is a meteoroid that vaporizes as it enters the Earth's atmosphere, often known as a shooting star. If you saw one, what would you want? A meteor that strikes Earth without igniting in the atmosphere is called a meteorite. A meteor shower is a group of meteors that are seen as Earth travels through a comet's cometary track. During specific times of the year, such as the Perseids meteor shower in August, you typically see this in the sky. A rock or metal object larger than a meteoroid that circles the sun is called an asteroid. In the past, asteroids were defined as objects larger than 10 meters. Now that we are aware of the variations among all of these items, let's discuss some recent events. A huge ship from the Oort cloud is approaching us. A cloud of frozen planetesimals known as the Oort cloud is purely speculative. It was first described by renowned astronomer Jan Oort. He suggested the cloud that is located between 0.03 and 3.2 light-years away from the sun. As of present, we are aware that Oort's cloud is composed of two parts, a spherical outer Oort cloud and a disc-shaped inner Oort cloud, which is known as the Hills cloud. The Oort cloud is thought to have originated closer to the sun and was dispersed widely into space early in the solar system's formation by the gravitational pull of the massive planets. It is noteworthy that even while the Oort cloud has not yet been directly observed with certainty, it may be the source of many centaurs and comets from the Jupiter family, in addition to the majority of long-period and Halley-type comets that approach the inner solar system. But what connection does the Oort cloud have to comets? Actually, because of how tenuously the outer Oort cloud is connected to the solar system, it is easily impacted by the gravitational pull of both the Milky Way and passing stars. Occasionally, these forces cause comets to be ejected from their orbits within the cloud and sent toward the inner solar system. And that is exactly where the source of our large comet is. Our comet, C/2014 UN-721, is 1,000 times larger than a conventional comet, making it probably the biggest comet discovered in modern times. We weren't aware it was a comet at first glance. Astronomers surmised that due to its large size, it might resemble a dwarf planet. But they soon understood their error. Instead, they were confronted by a massive comet. On June 23rd, the object was formally classified as a comet and given the name Bernardinelli-Bernstein Comet in honor of its discoverers, graduate student Pedro Bernardinelli of the University of Pennsylvania and astronomer Gary Bernstein. Do you wish to learn the size of this comet? This amazing ice body is roughly 10 times wider than a regular comet, with an estimated diameter of 62 to 124 miles. However, given how far the comet is from Earth, this is only a very preliminary estimate. The amount of sunlight a comet reflects is frequently used to estimate its size when it is far from Earth. And we determined its magnitude in this manner. But before we can make a more accurate calculation of its true magnitude, we must wait. Both bigger and smaller options are possible. The orbital parameters of the object were examined, among other things. According to astrodynamics, this amazing comet will reach our planet in 2031, but it will still be quite a distance away. We have the honor of having found what may be the largest comet ever observed, or at least the largest comet that has been well researched, and we caught it early enough for people to watch it change as it gets closer and warms up, according to Bernstein. Yet how did they discover it? The Dark Energy Survey, or DES, archived photos were being examined by astronomers. The Dark Energy Survey is an international, cooperative effort to scan billions of galaxies, find patterns in cosmic structure, and identify thousands of supernovae that will help us understand the nature of the enigmatic dark energy that is speeding up the expansion of our universe. On August 31, 2013, DES began scanning the southern skies. DE-CAM, one of the most effective wide-field CCD imagers in the world, was created especially for the DES and ran from 2013 to 2019. At Fermilab, a DOE facility, DE-CAM was created and tested. Currently, DE-CAM is employed for initiatives that span a vast array of science. In addition to the 300 million galaxies that were supposed to be mapped over a 5,000 square degree area of the night sky by DES, comets and trans-Neptunian objects were also frequently seen throughout the 6 years of observations. Ice-covered objects in our solar system that are located beyond of Neptune's orbit are referred to as trans-Neptunian objects, or TNOs. Using the National Center for Supercomputing Applications and Fermilab, Bernardinelli and Bernstein discovered the comet by recognizing 800 TNOs from historical survey data. In the period between 2014 and 2018, the comet's photos initially failed to exhibit a typical tail. However, a further independent observation in 2021, after the comet's discovery, revealed the comet now has a coma of gas and dust encircling it. Bingo! Let's explore what we can tell about the comet's location in the solar system right now. Currently, Comet Bernardinelli-Bernstein is situated about 20 astronomical units from the Sun, which is the same distance from the Sun as Uranus. The distance between the Earth and the Sun, or 1 AU, is roughly 93 million miles or 150 million kilometers. Unfortunately, the comet is not very bright because it only shines at magnitude 20. We are extremely sorry for the inconvenience, but if you are an amateur astronomer, this implies that your telescope won't be able to see it. For the sake of comparison, let's say that in complete darkness, the majority of people can perceive objects with a magnitude of 5 or 6. Keep in mind that the magnitude scale has a peculiar relationship. A larger magnitude equates to a lower brightness. Therefore, we stated that the comet is actually 20 Australian dollars away from us. What will its proximity be throughout the following years? The comet will still be near 11 Australian dollars when it swings closer to Earth in 2031. This indicates that it will be slightly farther from the Sun than Saturn's orbit. Amateur astronomers will still require very powerful telescopes to observe it even then. This comet dislikes having its photo taken. But what is so unique about our Bernardinelli-Bernstein comet? Our large comet is unique in that it hasn't traveled through the inner solar system in 3 million years. Our illustrious ancestor Lucy was still alive and well at that time. What will occur after that? The astronomical community will undoubtedly monitor Comet Bernardinelli-Bernstein since we need to comprehend the makeup and origin of this enormous object. Furthermore, the Oort cloud, which lies beyond Pluto and the Kuiper belt, may contain a large number of additional undiscovered comets of this magnitude. Additionally, they might help us better grasp how our solar system formed and evolved. Finding massive objects like Comet Bernardinelli-Bernstein is essential to our knowledge of the early history of our planetary system, since it is believed that these big comets were dispersed to the furthest regions of the solar system by the migration of Jupiter, Saturn, Uranus, and Neptune. Some of you might inquire, we are aware that we are capable of sending comet probes, just as we did with the Rosetta expedition. Will the scientific community deploy a spacecraft to this massive comet then? It's difficult to forecast and difficult to say, therefore. The lifespans of ground-based scopes are often longer than those of space missions. However, there is still a chance that a future telescope or mission will receive funding by 2031 for comet observations that have not yet been authorized or even planned. As happened in 2014 when Comet Sighting Spring flew by Mars, the major space agencies may likewise assign current spacecraft from all over the solar system to observe Comet Bernardinelli-Bernstein. While we wait, enjoy these breathtaking photos taken by the Rosetta mission of the Comet 67P/Churyumov-Gerasimenko as it approaches the Earth. Initial plans for the Rosetta mission included a meeting with Comet 46P/Wortinen. After the first launch was delayed, Comet 67P/Churyumov-Gerasimenko was chosen as the new target, and during the spacecraft's 10-year voyage there, it also passed by 2 asteroids. The primary goal of Rosetta was to approach and enter orbit around Comet 67P/Churyumov-Gerasimenko in order to conduct observations of the comet's coma and nucleus. The first comet landing ever was accomplished by Rosetta's Philae lander on November 12, 2014, at 17:32 Greenwich Mean Time. Here's where the video ends. Thank you everybody for watching. How do you feel about this video? Tell us in the comments section below. Remember to spread the word as well. Science needs you, and you need science. I'll see you again soon with another breathtaking video.